Are you tired of the limitations of standard business apps? What if you could build something that is not only beautiful and lightning fast, but also intelligent? Today we are shattering the boundaries of low code. We are taking the power of React, the speed of Vite, and the rock solid foundation of TypeScript. We are styling it with the gorgeous Fluent UI, and we are plugging it all directly in the Power Platform with a simple SharePoint list as our backend. But the real magic, we are injecting a powerful AI model to extract the skill from a long description in real time. This isn't just a concept, this is a fully functional PowerApps code app, and I am going to show you exactly how to build it. Stick around. Now I am on my desktop. Here I will initiate my Vite application, and for that I will run npm create Vite latest, and the name of my application AI powered skills users app. Then dash 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 template React TypeScript. This will initiate my application on my desktop. You can initiate your application on any folder you want. You can create a folder on your desktop or somewhere else and initiate your Vite application. As I said, this requires some experience with React framework. And here I am asked if I agree or not. I will press enter to agree. Now let me move to it and open the Visual Studio Code. When the application is opened in Visual Studio Code, I need to install all the packages that are in this file. So for that, I need to open a new terminal, and here I should type npm install and hit enter. This will install all the packages that are here in this package.json, and once this installed, I have to update Vite configuration. At this time, the Power SDK requires the port to be 3000 in default configuration. So for that, I should update this file, and as mentioned in the document, it should be exactly this way. I will save it, and I should install types node because we pick TypeScript variant. So here, and for the development, I need to install types node. So here I will run npm install dash dash save dev types node. So now to test my Vite application, I can run npm run dev. This will run this script. So my application is running on 3001. That means that the port 3000 is still used by other applications. So I need to verify and rerun my Vite application. So I will verify. I've verified and killed that. I verified and stopped that application. Now if I rerun this npm run dev, it should run on port 3000 now. That is so. If I click on this localhost, if I click on this link localhost with port 3000, I will find that the application is running on port 3000. Now I'll stop this, and now I have to authenticate the Power Platform CLI against the Power Platform tenant. So To do that, I have to run this command back of create. Then this will make me able to log in to my Power Platform account. But as I am already authenticated, I will list what do I have, what all the environments I have on my tenant. This will list all the environments I have on the tenant. And as you can see, I am already authenticated and selected this environment. So if you want to select another environment, you just type back in the select, then the URL of the environment you want. Let me clean this terminal, and I need to initialize my code app. To do that, I need to run this command using Power Platform CLI back code init -- display name, and here I will type my application name. So AI powered skills users app, and I will hit enter. This will initialize my code app, and as you can see, my application, my code app has been initialized, and as you have just remarked, I have this new file here, and inside this file I have the name and my environment ID and etc. We will come back later here to see when we add SharePoint list as a data source. Okay, one of the most important steps is to add a Power SDK. And as Power SDK is always and is still on GitHub, we need to run this command npm install -- save dev and the URL to GitHub repository. Okay, and we hit enter. This will install the Power SDK we need. So when we run this application, we will have two servers, the local server, Vite server, and Power SDK server. That will give us an idea about how the application will look like on our Power Platform environment. Okay, so to be able to run Power SDK server with Vite server, I have to modify this dev script here. This object, this key, and the value should be start back code run. This will run my Power SDK server, and Vite, this will run Vite server, this one. Okay, we'll save this. The next thing to do, this is the application. Okay, I need to wrap my application with a Power SDK. Okay, so to do that, I have to create a new file called Power Provider TypeScript, and here I should paste these lines of code as it is mentioned in the document, and this provider will initialize Power Platform SDK. Okay, here on main I need to import the provider and wrap the app with this provider. I save this. Once all of this done, we will have finished the setting up of our local environment to develop an application for our code apps. And if I run npm run dev, this will run my application on Vite, and also it's running on localhost. This is Vite application, and here is Power SDK server. So I can copy this, open another browser, and paste this here and hit enter. Great. Our application is also running on our Power SDK server. This is Vite server, this is Power SDK server. Okay, now as this done, also all the configuration on the local machine is done. We are ready to start our code apps development and add other functionalities like calling SharePoint lists and adding some AI functionalities. So let us move to the next step. Now let us add our data source, and our data source now is a SharePoint list. So to do that, I will open a new terminal, and this terminal, I will run this command back connection list. This command will mention or will list all the connections I have on my environment. As you can see, I have this connection, okay? The ID, name, and the API. The ID, name, API, and status connected. If you don't have this connection, that means that you are not connected to SharePoint on your environment. So to do that, you need to open your Power Platform environment and make sure that you are connected against your environment where your application is initialized. Against your environment, you use it in your Power Platform CLI, okay? And then you click on add a new connection, and here click on connections and make sure that you are connected against your, and make sure that you are on your environment, the environment you are authenticated against in your Power Platform CLI. Then here you click on add a new connection. Look for SharePoint, then add this connection, create, and I already have this connection on my environment, as you can see, and the status is connected. Once this done, now you can add your SharePoint list. To do that, I will make this a larger so you can see what I am doing. I will run this command back code add data source a shared SharePoint online, then C, and this is your connection ID. This is the connection ID, and then your SharePoint site URL, then your SharePoint list ID. If you don't know where to find your SharePoint list ID, you will find it here. This is the SharePoint we are going to use, and if you don't know what is its ID, you just click on this settings, then list settings. Once you click here, the URL will show you what is the ID. It's always from B to % symbol. So this one for my SharePoint list. Then you just hit enter, and this will generate the models and the services. So here we will have the model and services folders. Perfect. Data source utilisateur has been added to the app, and here is the models and the services. So here is the model for my users. Utilisateur in French means users, and here is the services. These are the methods I will use to make CRUD operations, okay, against SharePoint lists. Now I'm sure my backend is set up. For the sake of time, I will paste all the CSS code. So here for styles, this TypeScript file contains some objects of CSS. This will help me implement the new morphism styling. We'll save this. Also for the app CSS, I need to update this. I need also to update index CSS. Okay, I don't need all of this styling, so you will find all of this on my GitHub. So just follow for now, because the most important is coming. On my source folder, I have to add a folder called component. Inside this folder, I will add two files. The first file called skills model. Second file called user gallery. Now let's start with user galleries. First things, we need to import all the tools we are going to use. Think of this like gathering your ingredients before you start cooking. From Microsoft Fluent UI library, we are grabbing a bunch of pre-built components like text, avatar, and button. We are also importing special function or hook called makeStyles, which will handle all our CSS. From the icons library, we are grabbing a nice edit icon. And finally, we are importing our data types. This tells our component what a user object looks like, and our custom neumorphism styling object to give our app that cool modern look. Next, we define our component contract using a TypeScript interface. This is super important because it tells us exactly what this component needs to do its job. It needs two things. First, an array of users. Okay, that's the data we are going to display. And second, a function called onEditSkills. This is our communication line back to the main app. When a user clicks the edit button on a card, this function will fire off and tell the main app which specific user needs to be edited. Now for the fun part, make it look good, we are using Fluent UI makeStyle. Okay, this makeStyles hook, it is to define all of our CSS right here inside our component file. This is amazing for keeping things organized. We are setting up styles for everything. The main wrapper here, a responsive grid here that will automatically arrange our cards. Okay, the user card itself with that cool neumorphic hover effect, and the smaller styles for header and user info and footer sections inside each card. This one object will control the entire look and feel our gallery. Okay, here is the core of our component. We start by calling useStyle. We start by calling useStyles to get our styles ready. Okay? Then we set up the main layout with a wrapper. The real magic happens with users map. This function loops through every single user in our data array. Inside the loop, we do some important data cleanup. For display name, we safely check for the name in a couple of different places in our data. For picture URL, we grab the link to their profile photo, and for skills, we do this cool little transformation. We take the raw text from SharePoint, split it into an array, trim any extra spaces, and filter out any empty items. This turns messy data into a clean array we can easily work with. And to return here, I want this component to return the actual JSX that to create the visual card. We give it a unique key which React needs for performance. The header contains the avatar, which smartly shows the user's picture or their initials as a fallback. The skills container uses a cool trick called a ternary operator. It checks if there are any skills. If so, it displays them as tags. Else, if not, it just shows no skill listed. Lastly, the footer shows the job title and our edit skill button. When this button is clicked, it calls that onEdit skills function we talked about, sending this specific user's object up to the main app to trigger our AI model. I need to correct the path to this model. Okay, so here, and that is it. I will save, and by doing that we have finished our user gallery. Now let us move to skill model. Before building skills model, I need to build a AI service because there is a function inside that I need for skills model. So here I will create a folder called AI. Inside I will create a file called AI service. And here, this file is going to be our bridge between our beautiful React UI and the powerful AI capabilities of the Power Platform. We are going to keep this super clean and simple. Let's get into it. First, we have this flow URL. This URL points to a Power Automate flow that we haven't built yet. Think of this as a placeholder for now. In few minutes, we are going to jump into Power Automate, create a flow that calls our AI builder model, and it will give us a unique URL. We are just setting it up so our code knows where to send the request. This is an async function, which means it can handle operations that take some time, like calling an API. It takes one argument, the description, from our UI, and it promises to return any array of strings, our suggested skills. This block try and catch. Then we have this block try and catch. The entire logic is wrapped inside this block try and catch. We create a simple request body object that holds the description we want to send. Then we use the standard browser fetch API to make a post request to our flow URL. After the fetch call, we immediately check if the response was okay or not. If we get back an error from the flow, we threw an error, and this code will grab that error message and throw a new, more descriptive error in our app. And finally, if everything is successful, we get back the text from the flow's response. We do a little bit of cleanup. Power Automate sometimes wraps its text response in quotes, so we use a little regex to remove them. Then we do our data pipeline trick split. This split will split the string into an array of skills, map over them to trim any white space and filter out any empty ones, and that is it. We return our clean array of skills. Before building the Power Automate flow, we need to set up our skills model. We start with our import. We import use state from React. We are bringing in a bunch of components from Fluent UI, dialog for the pop-up, text area for our input box, and spinner for loading animation. We are also importing our two key services: suggest skills from text, and utilizer service, which lets us save the new skills back to SharePoint. Suggest skills from text, which is our connection to the AI. The props for this model are also really important. It needs to know which user is being edited, okay? A function to on close the model, and a function on save. It can tell the main app to refresh the data after we've saved our changes. This is the brain of our component. We are using React use state hook to keep track of everything that can change on the screen. Skills is an array that holds the user's current skills. Project text stores whatever the user types in the text box. And then we have three flag states: is suggesting, is saving, error. These are simple booleans that we will use to show loading spinners or display error messages. This is the key to creating a responsive and user-friendly interface. Handle suggest. Now for the AI magic, the handle suggest function is what runs when the click the suggest skills button. First, its set is suggesting to true, which will show our spinner. Then inside try and catch block, which is essential for handling any potential errors, it calls our suggest skills from text service, passing the user's project description. When the AI sends back the new skills, we do a cool trick with JavaScript set to merge the new skills with the old ones, automatically removing any duplicates. Finally, whether it succeeds or fails, the finally block sets its suggesting back to false to hide the spinner. Once we have the skills we want, we need to save them. The handle save function does this. It shows a saving spinner and then calls the user service update function. We pass the ID of the user we are editing and update skills field. Notice we use skills join to convert our array back into a single comma separated string, which is how SharePoint expects to store it. If the save is successful, we call the onSave function, which tells our main app component to close the model and refresh the user list to show the new data. Finally, we have the JSX that creates the visual part of our model. First, a quick safety check: if user does not exist, return null. This just means if for some reason there is no user selected, don't render anything. The main component is Fluent UI dialog, which gives us the nice pop-up effect. Inside the dialog, we have dialog title, which shows the user's name. We have our text area where the user types their project description, and here is our main button. Notice how its text and disabled state are tied directly to our state variables. If is suggesting is true, it shows a spinner. If is suggesting is a true, it shows a spinner. If not, it shows the suggest skill text. This is what makes a React UI feel so alive. We then display the current skills using our tag group. Show an error message if one exists. We have dialog actions with cancel and save button. Just like the suggest button, save button also shows a spinner when it is working. This whole structure is driven by the state we defined at the beginning, making the UI a direct reflection of the component's internal brain. This is the moment we have been building up to. We've created our AI service, our user gallery, and our skills model. Now it is time for the grand final. Let us assemble everything in our main app file. This component is going to act as the conductor of our orchestra, managing all the state and telling our other components what to do. So first of all, let me get rid of what this component is returning for now. I will replace it with a simple div. Then here I will just type a h1 hello and save this. This will be updated, as you can see. Now I need to import things here from React. Use state and use effect hook. Also use call back. I don't need this. I will import also utilizer service from service. Yes, I also will import the user gallery we've built here from user gallery. Also, I will import skills model component from skills model file. Next, inside our app component, here I need to import utilizer, so I will just import it. So this our component, we set up our application's central state. Think of this as the brain of our app. We are creating 5 pieces of memory. All users is our master list of data from SharePoint. Filter users is the list that actually gets displayed, which is how we will implement searching. We have is loading and error flags for a good user experience. And finally, editing user. This is the most important one for our interactivity. When it is null, our AI model is hidden. When we set it to a specific user, the model will pop up. Now let's get our data. Fetch data. We create a function called fetch data that is responsible for calling our auto-generated user service to get all the users from SharePoint. When the data comes back, we'll load it into both all users and filtered users. We then use the use effect hook right below here. This special hook tells React to run our fetch data, this function, exactly once, right when the application first loads on the screen. Okay, our app needs to respond to user actions, and these are the functions that handle that. Handle search is connected to our search bar. Every time the user types, it filters our master all users list. Every time the user types, it filters our master all users list based on the name and the skills of the user. Then it updates filtered users state, which makes gallery update in real time. Handle save and refresh is a crucial piece of communication that will pass to our model. When the model successfully saves new skills, it will call the function fetch data. Again, ensure our gallery is always showing the latest information. And to keep our final JSX clean, we are using a helper function called render content. This is a really common pattern in React. It simply checks our state. If is loading is true, it shows a spinner. If there is an error, it shows the error message. Otherwise, it returns our user gallery component. Notice how we pass the filtered users to the gallery, and we also pass the set editing user function. This is how the gallery card will be able to tell our app component which user to edit. And here is the grand final for this component, app component, where we put all the pieces together. We have our main app layout. Here you can press Control key on your keyboard, then you press the space key on your keyboard, and this will import it just here. As you can see, I have imported this one and this one using my two keys on the keyboard, Control and space. Same thing with input. I press Control key, then space key, and here we go. It proposed to me to import it from Fluent UI. The same thing with Web Light theme. We have a main layout with a header here, with a header for the title and search bar. Okay, the content area just here below, it calls our render content function to display the gallery. And setting right at the end is our skills model. We pass the editing, the editing user from our state, which determine if it is visible or not, and we give it on close and on save functions so it can communicate back to us. This is the declarative nature of React. We simply describe what the UI should look like based on our current state, and React handles the rest. Okay, with all the pieces in place, I'm going to save this file, and we will see right here on the browser the final result. And here we go. I have just saved this app, and we have our application running on Power SDK. So if, for example, I want to open the skills model for Mohamed-Lamin, I will just hit this edit skills, and that will open the model, as you can see. That's good. I can see if it is really perfect. That's so good. Now, to be able to test the AI here, because here there is nothing fail. I have worked, or he worked on project that required skills like React and Express. then I hit suggest skill with AI, there is nothing, failed to get the AI. So to test this, I need to implement the flow, because when we call this suggest skills from text, there is no URL. Fetch here has no URL to call to send HTTP request post method. So let us implement our flow. And now let us jump into Power Automate portal. I am now on Power Automate portal and I will create a new flow. This flow, it should be an instant flow. And here I should look for HTTP request when HTTP request is received. This one I will create, and I will call this flow skills extractor flow. Here, for who can trigger the flow, I will pick anyone. I don't recommend this option in production. For the schema, I will generate the schema using a simple payload, and the simple payload is this one. The key is description and the value is a string. We are looking for a software developer with experience in C# and .NET and Azure. So done. This will generate the schema. Schema generated. I will click on show all and scroll down. I don't need relative path. Then the method should be post, which means that the trigger will wait for a HTTP request with post method and data in the body. Okay, now I will add a new action, and this action should one of AI capabilities, which will be the first one, run a prompt. So you wanna use that awesome AI prompts. Maybe Microsoft uses something called AI Builder credits. Think of it like a pay per user system. Your premium Power Automate license gives you a small bucket of credits for free each month, which is perfect for trying things out. For any real world use, you will need a plan to get more AI Builder credit. So let me here create a new custom prompt. And here it will open this window. So here I will give it a name. I will call it skills extractor. Okay, and here I should give it instructions. So based on these instructions, it will treat the prompt. So the instructions are the following. You are an expert skills analysis assistant. Given the following project description provided by a user, extract a list of professional skills. Return only a comma-separated list of skills and nothing else. Do not add any introductory text or explanations. Example output, this output, project description. So to test it, I will give it, for example, here, I will give it the description here, and I will say I worked on a project that required React and Express, also PostgreSQL, and I will test. Here we go. Awesome. Now, instead of a constant description, it should be dynamic, because each time our application, our code apps will send a description, this prompt should treat it. So I will add here add a content here. When you click on add content, you have a text, image or document, PowerApps, and also other connection, also Dataverse. So our value, our description, it's of type text. So I added a text already here. So I will rename it. Okay, no need for simple data. Save this. Prompt has been saved. Awesome. Our prompt is saved, and here the description will be a dynamic as I said, and it should come from the trigger. So here, description. When it finishes treating this description and extracting the skills, it should send them back to our application code apps. So here I will look for HTTP response here, and it should be 200 because that means that the flow has been successfully run. No need for another body here, don't need anything to add here. So we will save our flow and get the URL. Once it's saved, we should find the URL generated here, and we copy it. Then we go back to our application and start using this URL. Great, the URL is here. I will copy it. Then let us jump back, continue the test. Now I am back to the application, and we can first of all see the SharePoint that we will use the application against. This is the most important column. It's a person column of type person, and it has for each user his name, email, image, and job, etc. So that is why I picked it. So here is also the skill column. It is of type text. And now I copied the URL for the flow. I will paste it here and I will save this. Okay. Before we test, we should know that this function suggests skills from text, takes a description parameter of type string, and this will be the variable here in this variable. This is a of type object, this variable. The key is description, and the value is this parameter that suggestion skills from text function takes. Then the HTTP request of type method send to our flow this data, which is this object that looks exactly as the schema we have on our flow. Then we have the other part of the process. Here we use some JavaScript functions to get exactly an array of skills. Now let me test this. I will test it with Adele, and here I will type she worked on projects that require React, Express, and also PostgreSQL, and I will click on Suggest Skills with AI. And as you can see, React, Express, PostgreSQL. The flow returned these values because it's used the prompt, the AI builder prompt. Now I can cancel or save. When I save, I will find this value in the column of skills in SharePoint list. So I will click on save. It's updated here. The application retrieved the value from the SharePoint list here. Okay, if I refresh this, we should find exactly here is the skills that steadily has. Now, as you can see, we can say that we have built an application using PowerApps codeapps. It's always running on local machine. Now we should push it to our Power Platform environment. So to do that, I will run this command back, codeapp push dash dash path. This will push the application. This will push the application to Power Platform environment.